So inverse functions, we have 4 steps to find inverse functions. So step number 1, we're going to replace f of x with y. F of x is just function notation. Sometimes it's g of x, h of x. We're taking that function notation out and we're going to replace it with y. Second step, we're going to flip x and y. Sometimes you'll hear that as invert, which is where the word inverse came from. You're going to invert them, flip the x and the y. Your x becomes y and your y becomes x. Step number 3, you're going to solve for y. That could take a few steps just to do that. And then our last step is to take y back out and replace it with f inverse of x. So this is just the notation that tells us, hey, we took the original function f. The little -1 up there tells us that we took the inverse of it and the variable is still x. So let's try the first one. Step 1, we're going to replace f of x with y. So here's my equation. I'm going to take f of x out and I'm going to replace it with y. So that's step 1. Step number 2, we're going to flip x and y. So instead of y equals, we're going to have x equals -5y minus 4. That's step 2. Step number 3, our objective is to solve for y. So in order to get y by itself, we might have to work through a few steps. In this case, we've got 2 steps to get y by itself. First step would be to add 4 to both sides. So x plus 4 equals -5y. For our next step, we need to get rid of the -5 that's in front of y. We're going to divide both sides by -5. And then remember back from algebra, you never want to leave a negative in the denominator of a fraction. So in this case, we would want to take and change all the signs in this entire fraction. So if we do that, we're going to have -x minus 4 divided by +5. So we changed all the signs in that entire fraction. So now we've solved for y. The last thing we need to do is replace y with f inverse of x. And this right here is our final answer. All right, question number 2. All right, step 1, we're gonna replace f of x with y. So that's step 1. Step number 2, we're going to invert or switch our x and our y. So now we have x equals negative 5y plus 15, all divided by 7. For our next step, step number 3, we want to get y by itself. In this case, it's going to take us a few steps to get there. The first thing we want to do is eliminate this fraction on the right-hand side. Easiest way to do that is to multiply both sides by 7. So when I do that, 7 times x is 7x on the left-hand side. And then the 7s cancel each other out on the right side, leaving us with just negative 5y plus 15. Subtract 15 from both sides. So 7x minus 15 equals negative 5y. Pause. I have a negative in front of my 5 that doesn't exist. So if you look back up here, this 5 was positive, and for some reason I wrote a negative. So go back through and get rid of those negatives. So I'll give you a second to fix that. My apologies for that. Now we want to divide both sides by 5. That's going to give us y equals 7x minus 15. All divided by 5. And then for our last step, we want to replace y with f inverse of x and that right there is your final answer. All right, moving down to the next one. Now we have g of x equals -2 plus 1/5 x. So first step, we're going to take g of x out this time, and we're going to replace it with y. So y equals -2 plus 1/5 x. Step number 2, we're going to invert or switch our x's and our y's. Step number 3, we want to solve for y. We want to get y by itself. So we're going to start off by adding 2 to both sides. So x plus 2 now on the left equals 1/5 y. In order to eliminate the fraction that's in front of y, we want to multiply by 5/1, which is just 5. So we're going to multiply both sides by 5. On the left-hand side, we can either leave it as 5 parentheses x plus 2, equals 1y, or if you want to go ahead and multiply 5 times x to get 5x and 5 times 2 to get 10, that would work as well. And then either one of those answers, you're going to take y back out and replace it with g inverse of x. So either one of those answers would be acceptable. You do not need to have them both. Just one is good, whichever way you prefer. All right, next one, we have h of x equals 3/7 x minus 9/7. So for this one, again, the same 4 steps. We're going to start off with taking h of x out and replacing it with y. So y equals 3/7 x minus 9/7. Step number 2, we want to switch our x's and our y's. So x equals 3/7 y minus 9/7. Now, when I look at this, some students begin to panic because there's so many fractions. Thankfully, in this case, both fractions have the same denominator. In this case, they're both 7. So if we multiply both sides by 7, the left-hand side, we're going to have 7 times x, which is just 7x. On the right-hand side, we're going to take 7 times 3/7, which is going to simplify to just 3y. So 7 times 3 is 21. If you divide that by 7, it takes you back to 3. So multiplying by 7 and having a denominator of 7 are inverse operations. They just cancel each other out. We're then going to take the 7 times the negative 9/7, and the same thing's going to happen there. You're going to cancel out the 7s, multiplying by 7 and dividing by 7, inverse operations to cancel each other out. So that's just going to be minus 9. Now this looks a lot easier to solve for y. So take a moment and go ahead and finish solving this one for y and write your answer in inverse notation. So hopefully when you solve for y, you got 7x plus 9 all divided by 3. And then when you write that in inverse notation, you want h inverse of x equals, and then the 7x plus 9 all divided by 3. And that right there is your final answer. All right, making things a little bit more challenging, we're going to start throwing in powers and roots. So I've got you a little note down here at the bottom. Remember to undo powers, you want to take the same root. So if I'm trying to get rid of the fourth power, I need to take the fourth root. If I'm trying to get rid of the fourth root, I would take it to the fourth power. So our 4 steps stay the same. It's just we need to remember if we're trying to get rid of a power, we're going to take the same root. If we're trying to get rid of a root, we're going to take the same power. So now we have f of x equals -3 plus, and then in parentheses, x minus 2 squared. So our first step, again, take f of x out, replace it with y. That's all we're doing for that first step. Step number 2, we're going to invert or switch our x's and y's. So x equals -3 plus y minus 2 in parentheses squared. I'm still wanting to get y by itself, but notice y is stuck in this set of parentheses. So since y is stuck in that set of parentheses, I need to get that set of parentheses isolated by itself by adding 3 to both sides. So that's going to give us x plus 3 on the left-hand side equals the y minus 2 in parentheses squared. Now remember I said a couple minutes ago that if you want to get rid of a power, you need to take the same root. So in this case, the power I have is 2. So I need to take the second root or the square root. If I take the square root of one side, I also have to take the entire other side and find the square root of it. So I don't know what the square root of x plus 3 is, so I'm going to leave it as the square root of x plus 3. Remember, since this is a square root, we don't have to write that little 2 in there. It's assumed because square root's the most common. And then on the right-hand side, when I square a square root, or square root a square, this is going to cancel with this, and it's just going to leave us with y minus 2. And the last step to get y by itself would be getting rid of that minus 2 by adding 2 to both sides. We have to be careful. When we add 2 to the left-hand side here, we cannot add it together with that 3. It has to go out at the end. You'll see some people put little end marks on their square root signs. So do not combine the 2 and the 3 because the 3 is underneath the square root and the 2 is not. So then I'm going to go over here to the left-hand side to write my final answer. F inverse of x equals the square root of x plus 3, and then plus 2 out at the end. All right, next one. So in this case, we have a function, the fifth root of x plus 1 minus 2. Step number 1, we're going to take f of x out and replace it with y. So y equals the fifth root of x plus 1 minus 2. Step number 2, we're going to switch our x's and our y's. Step number 3, we need to get y by itself, but right now y is stuck underneath this fifth root, underneath that radical. So in order to get the y out from underneath the radical, we first need to isolate it. In order to isolate it, we're going to add 2 to both sides. So we have x plus 2 on the left-hand side equals the fifth root of y plus 1. In order to get rid of the fifth root, we need to take this side to the fifth power. Remember, fifth roots and fifth powers cancel each other out. If I raise one side to the fifth power, I also need to raise the other side to the fifth power. So I now have x plus 2 to the fifth power. Now I know that x plus 2 to the fifth power actually means x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. You do not have to multiply that out. You're going to leave it as x plus 2 in parentheses to the fifth power. So don't multiply all that out. If it's anything higher than 3, don't multiply it out. And then on the right-hand side, your fifth root and your fifth power cancel, leaving you with y plus 1. Last step to get y by itself would be to subtract 1 from both sides. And same scenario as last time, I cannot combine that minus 1 with the plus 2 because it's inside those parentheses. So I'm going to write it out at the end. So I have x plus 2 in parentheses to the fifth minus 1. Equals y. So last step, we want to take y back out and we want to replace it with inverse notation. So f inverse of x equals, and then I'm just bringing the x plus 2 in parentheses to the fifth minus 1. All right, last one down here. We have a function g of x. So with g of x, we want to start off by replacing it with y. Now, when we look at the right-hand side in this case, the third root comes all the way down here to the bottom. That means that that 2 in the denominator of this fraction is included underneath that cube root. So in order to eliminate that cube root, I have to take both sides. Oh, I skipped a step. Switch your x and your y's first. And then we're going to get rid of the cube root. By taking everything to the third power. So on the left-hand side, we have x to the third, which is just x to the third. The cube root and the cube cancel each other out. And we now have this fraction negative y plus 2 all divided by 2. Next up, we want to eliminate that fraction, so we're going to multiply by the denominator. Going to multiply by 2. Multiply the left-hand side by 2. So 2 times x to the third is 2x to the third. On the right-hand side, we're going to have negative y plus 2. Then we're going to subtract 2 from both sides. So 2x to the third minus 2 equals negative y. We can either multiply both sides by -1 or divide both sides by -1. It doesn't matter. I would just go ahead and do my multiplication. So if I multiply the left-hand side by -1, I would have -2x to the third plus 2. Because again, you're multiplying that -1 by both terms on the left-hand side. And then on the right-hand side, negative y times -1 is positive y. And last step here, we're going to take y back out and we're going to replace it with g inverse of x.